In this video, I'll be teaching you derivative of a product, otherwise known as product rule in differentiation. So what do we mean by derivative of a product or the use of product rule to solve differentiation? So when we have y equals to uv, where u and v, where this u and v are functions of x, so we should be able to tell that y becomes plus the y equals to open bracket u plus du, close bracket, open another bracket, v plus dv. You know this we are doing. If you haven't watched our previous video, please go and watch before you understand this. So we are trying to derive the product rule formula. So this will give us y plus the y equals to u times v, give us uv, then u times the v give us u dv, and the u multiplied by v gives us v du plus dv multiplied by du, that gives us du dv. So now that we have this, let's take our y to this side. So the y is equals to uv plus u dv plus v du plus du dv. Now this y will now come here, becomes minus y. So what's the value of y? Remember, it is uv. So uv plus u dv plus v du plus du dv minus uv. So minus uv plus uv, so this cancel this. So we are left with the y. We are left with the y equals to u dv plus v du plus v du plus du dv plus du dv. Now that gives us to dividing both sides by dx. Remember that when we differentiate, we have the y dx, right? So to divide all through by dx, we have the y dx is equals to u dv plus v du plus du dv all over dx, and each of them can carry this dx. I believe you understood that. So that takes us to dy dx is equals to u dv dx plus v du dx plus du dv all over dx. So when we take the limit of dx to tend to 0, everything here becomes 0. So we are left with the y dx. If you have not watched our video on limit, please go and watch so that you understand how dv du divided by dx can just become 0 by the limit of dx to 0. So dy dx is equals to u dv dx plus v du dx. So this we call the product rule. So this we call the product rule. So we use this product rule to solve differentiation, of which two different variables are functions of x, where two different variables are functions of s. So let's take an example. Example number one. Example number one says we should solve y equals to open bracket 3 plus 2x open bracket 1 minus x. So you can see we have u and we have v. So let's get into the solution of this problem. So now that we know that our u is equals to 3 plus 2x and our v is equals to 1 minus x, let us take our formula, the y dx, saying equal to u dv all over dx plus v du all over dx. So what is the value of u now? 3 plus 2x before we go into 3 plus 2x, why can't we find the v dx? Okay, it's as simple as something we can just look at and do. So let's get it done. 3 plus 2, that is our u. 3 plus 2x multiplying the v dx. This is v. So to differentiate the v dx, when you differentiate 1, you have 0. When you differentiate x, you have 1, because we have 1 here. So when this one comes here, it becomes 1 multiplied by x. Then 1 minus 1 is 0. So x raised to the power of 0 is 1. So everything here is 1. So the v dx is 1 plus, what's our v here? Our v is 1 minus x into bracket multiply the u dx, that is differentiate u. When you differentiate u, this 3 becomes 0, and then 2x becomes 2. How? Because there is 1 here. So when that one comes here, 1 multiplied by 2x give me 2x. Then 1 minus 1 gives 0, making x to have a superscript 0. Now that superscript makes